So I'm going to start off with an example of graphing a system of inequalities, maybe one that's just a little more complicated than what I did the other day. And then I'm going to move into section 7.3 where we're going to apply this stuff to start actually solving some problems. So, but first, let's warm up with graphing a system. And I'm going to point out a few technicalities as we go that maybe some of you have been worrying about. So here's what we're going to do. Here's our system of inequalities that we're going to deal with. So this should look like, this is based off of a web work problem. So if you guys did your 7.2 web work, this should look sort of familiar. The numbers will be different, but anyway, this is the same kind of style as some of those web work problems. And so I figured it's worth doing. Clear, that's a 6y less than or equal to 60. So I have negative 6y is less than or equal to 0. X is greater than or equal to 0. 4x plus 2y is less than or equal to 64. And 3x plus 6y is less than or equal to 60. Okay. So there are a couple different things that make this just feel a little harder to deal with than our other examples. One of them is just there are big numbers. There's like 64 and 60. Also, maybe this is different than ones that I did in class. It's negative 6y being less than or equal to 0. So I just want to walk through how to deal with some of these so that if you encounter them again, it won't be quite so strange. So let me go ahead and do that. So we'll just approach this the same old way that we always would. Maybe I should I'll grab some colors here. Okay, so let's approach this like we did last week. I'm just going to go one by one and graph each of these inequalities, and then we're going to look for where everything overlaps in the end, and that's our solution. So let's do this one first. Negative 6y less than or equal to 0. So how does that work? Well, I need to graph the line negative 6y equals 0. So where is that? Well, you know, if I wanted to put this into slope-intercept form, I would want to get y by itself. So where is it true that negative 6 times y is equal to 0? Well, if I just divide both sides by negative 6, I'll get y equals 0. So I'm really looking for the line y equals 0. And if you guys remember, y equals 0 is just the x-axis. That's this horizontal line. That's where the y coordinates are 0. So this first line is just the x-axis. Now I'm asking for negative 6y less than or equal to 0. I could test a point to see where I should shade. If I take 0, 1, for example, then I'm above the line. That's 0, 1. So let's plug that in. That'll give me negative 6 times 1, which is negative 6, is less than or equal to 0. So negative 6 less than or equal to 0, that's true. So it looks like I should shade above the line, above this red line. So to keep my picture from getting super messy from shading all over the place, I don't know, maybe for now I'm just going to indicate above. We're going to shade above that line, let's say. Okay, so we shade above the x-axis from this first inequality. So the negative 6 is sort of like a trick. It kind of covers up what's really going on here. All I need to know is that I'm shading above the x-axis. Okay, this next one, x greater than or equal to 0. We kind of know how to deal with this one. I've done this one in several examples, I think. This has been one of our implicit constraints. I'd be graphing the line x equals 0, but that's just the y-axis. So the line I'd graph is the y-axis, and then I'm shading x is greater than or equal to 0. That means I'm going to shade to the right. So I'm shading to the right of this one. So far I'm shading above the red line and to the right of the purple line, so I know I'm up here in this first quadrant. I'm up here in this quarter of the plane, the upper right quarter, so far. Okay, now here come the more annoying inequalities. So for example, there's this guy. I don't know. Let's see here. Well, that shows up. I have this 4x plus 2y less than or equal to 64. Maybe I'll do this in black when I'm writing out. Just do the line in green. I have 4x plus 2y is less than or equal to 64. I would really like to graph this. So the first thing I'm going to do is find the line, the corresponding line where I turn this into equals. And I might want to put this into slope-intercept form so I can graph it easily. Let's do that. Let's put this into slope-intercept form. So I'd subtract 4x from both sides. So I get negative 4x plus 64 is equal to 2y. And then I'm going to divide both sides by 2. So I'm going to get y equals negative 2x plus 64 divided by 2 is 32. So y equals negative 2x plus 32. That's going to be my green line, my green shading. So here's an issue that I think one student brought up to me was, this is sort of annoying to graph because that's kind of a big number, right? This is our y-intercept, since this is in slope-intercept form. 32 is kind of a big number, and I don't want to draw 32 tick marks. And so if you're trying to graph these by hand and just doing tick marks counting by 1, it's kind of annoying because 32 is big. And like there might be bigger ones you come across. Like what if the y-intercept is 1,000 or something? What do you do? And so on the one hand, you could draw individual tick marks, but that's tedious and annoying. So what I would do instead is you are allowed, there's nothing saying that I have to count by 1 when I go up by these tick marks. These tick marks could represent any number of units that you want. So one solution to this is to say that instead of counting by 1s, maybe I'm going to count by 5s or 10s or 2s or 4s, whatever you want, whatever is convenient for the problem that you're doing. So maybe my tick marks go up by 5, let's say. So maybe this is 5, 10, 15, 20, 25, 30, 35, right? Maybe I'm counting by 5s. 5, 10, 15, 20, 25. If I'm counting by 5s, now instead of having to count 32 individual tick marks, maybe now I just need to get up to 32. I just have to go up, like 6 tick marks and then a little more to get to 32, right? So it makes graphing a little easier. There is one sort of trade-off here, which is that now if I'm counting by 5s, I don't have a tick mark exactly for 32. Now 32 is somewhere between 30 and 35. That's okay though. We'll just kind of eyeball it. We'll just kind of approximate it, right? So 32 is somewhere right here in between 35 and 30. And that's going to be okay for us. So I will make this clear now as far as my expectations for these graphs. Say on the exam, I require you to submit written work where you've drawn some of these graphs, which, spoiler alert, I will. You do not have to give me perfectly precise robotic graphs. What I need are generally correct graphs, but if you kind of just eyeball in between for a fraction or something, that's good enough for me. So I guess my point is your lines just need to be approximately in the correct place with like approximately the correct slopes, approximately the correct intercepts. And in the end, your shading just needs to be in the right location relative to your lines, right? If it's supposed to be underneath a certain line, then you better be shading underneath that respective line and so forth. But you don't have to have absolutely precise, I don't need you to get out your measuring like a ruler and find out exactly where 32 should fall between 30 and 35. It doesn't need to be that precise. So just get it approximately in the right spot. Yeah. You guys have seen me graph up here. I'm pretty sloppy, and that's okay. You can be as sloppy as I am. But I will point this out. If you do count with different tick marks, instead of just counting it by 1, please tell me what you're counting by. Either label them like I did. I labeled them by 5s. Or like write me a little message next to your problem that says I'm counting by 5s or something. Somehow indicate it so that I know what's going on. Otherwise, it's harder. It could be hard for me to decipher what you're doing. So when in doubt, tell me what you're doing somehow. So it makes my grading life easier. Okay. So anyway, that was a nice little detour. Let's get back on track here. So we're graphing this. I'm counting by 5s to make my life easier. So this is graphable. 32 falls somewhere between 30 and 35. And now I need to use the slope to find another point. The slope is -2, so every time I go to the right by 1, I should go down by 2. And the fact that I changed the tick mark values doesn't matter. It still works out that if I go to the right by 1 tick mark, I should go down by 2 tick marks. You know, so because what am I really saying? That says if I go to the right by 5 units, I should go down by 10 units. Right? Things will multiply by 2. So everything's okay. So I'm going to go to the right by 1 and go down by 2, aka I went to the right by 5 and I went down by 10. That's a slope of -2. And so this green line is going to look something like this. Okay, so far I have 3 lines like this. And again, everything's approximate because I'm using these tick marks and I kind of approximated where this should go, but that's fine. It's going to give me the generally correct picture, right? We'll still get the right amount of corner points and everything will be approximately in the right place. Okay, there's one more line to deal with, and apparently this marker doesn't work. Even though it's a brand new marker, that's pretty disappointing. I got gypped. All right, cool. We'll just do this one in black. That's really annoying. Okay, so we're going to graph this last one in black. So that's 3x plus 6y. Oh, and I forgot to mention on this one, where are we shading on this one? If we were to test a point, I'll leave this to you guys to check. Test a point for this line. You should find that we're going to shade underneath or below that green line. I should point that out. So we're going to shade underneath the green line. Okay. So for this last one, I need to graph the line 3x plus 6y equals 60. Let's solve this in the slope-intercept form. I'll get 6y equals -3x plus 60 by subtracting 3x from both sides. And now I'll divide both sides by 6. I'll get y equals -1/2 x plus 10. Okay. Now I have a slope of -1/2 and I have a y-intercept of 10. So I'm glad I have tick marks of 5 for this one because now I just go up to here. That falls right on the 10 tick mark. And now I just need to use the slope to find another line. Again, so the slope is -1/2. So when I go to the right by 2, I go down by 1. So when I go to the right by 2 tick marks, I go down by 1 tick mark. Like so. And this is where my sloppiness in graphing is going to come back and bite me in the butt a little bit. And we'll see why in a second. And I drew this too far. Because I draw an imperfect picture, but that's okay. So here we go. I have this line now, and it turns out, again, if we check by testing a point, where should I shade with respect to this line? It's also going to be below again. I should shade below that black line. So what I find is that all of my shadings, if I look, I'm shading above the red line, I'm shading to the right of the purple line, I'm shading underneath the black line, and I'm shading underneath this green line. Turns out I'm going to shade in this shape here. All my shading should overlap right here. Okay. So those are that's where my feasible set is. That's where all the shadings overlap. Okay, so the question now is, how many corner points do I have, and what are they? What are the corner points? And so this is why I'm complaining about my drawing a little bit. There are supposed to be 4 corner points here. So remember, one fact I told you guys on Friday was that generally, the number of inequalities you have will tell you how many corner points there should be. So there should be at most 4 corner points because I have 4. And probably there will be 4. In this case, there are in fact 4 corner points. So there's one here,